Okay, so let's begin.
Yes.
Now, yesterday we saw about terrestrial habitat. Okay, three types we saw: the animals living in the habitat of the mountains, forests, and deserts. Okay, all three are covered in plants. Now comes the water habitat. Okay, known as aquatic habitat. Okay, now this aquatic habitat is of two types. One with salty water like ocean, bays, and other areas, and second one with sweet water like river, ponds, lakes, waterfall, etc. Okay, now the organisms that live in ocean have to balance the salt in the body. If they are not able to do this, their body will move out in the ocean. Okay, so now, how do they manage the salt in their body? The gills of marine animals help in salt balance in their body through their gills. Okay, so their structure helps them in survival in water. Their body is streamlined, which helps them to move against the water pressure.
Managing of salt meaning?
Managing of salt means, like in the ocean has a lot of salt, like salty water. But what gills does, in the like fish, they take in the water, okay? Then just the oxygen is absorbed through the gills, and then the water comes out of their body, okay? So now, since the water comes out of our bodies, salt content is not absorbed, okay? That is why they are able to survive in the ocean, because ocean is all about very salty water. Oceans and seas have very salty water. Okay. Sweet water, it is okay. Sweet water like rivers, ponds, and lake waterfalls. Okay.
Mom,
That has
what does salt mean? Like, what are you saying like salt absorption?
salt absorption. See, if like they absorb salt, then they will just float out of the water. Okay. The fishes and all, they will just float out of the water if they will take in all the salt from the water, if the salt is absorbed in them.
Yeah, so it's just basically becoming less dense than water, right?
Less dense, yes. Basically, they'll become less dense. Okay. So they'll just float above water. But that doesn't happen because this like intake of water takes place, and then the after absorbing the necessary content, that is oxygen molecules from the water, the gills absorb it, and then the remaining just passes through out of the fish. Good morning, Anna. We just started with aquatic habitat. Okay, please turn on your camera. I was explaining that aquatic habitat is of two types. One is salty water, that is there in the oceans, seas, bays, and all. And the other one was sweet water, like the fun found in river, pond, lakes, waterfall, etc.
Ma'am,
Okay.
ma'am,
Yes.
ma'am, if I put like suppose you see like a dish shape, like how you call it? A triangular prism under the water, but I had it steep like this from like from one side it was steeping. So then because of the water pressure and the pressure is coming over here, then the pressure will push it ahead, right? Right, ma'am?
Um,
You should propel the triangular object ahead. So then ma'am you could have a self-propelling, like you could have it go from one place to another easily without using any energy.
mhm. Yes, but the thing is that it is not necessary that like for all the time you will get that much of like water pressure continuously, regularly, if it is natural. Okay, if it is natural, if you're depending on natural water pressure, So water pressure is never the same. Okay, sometimes it's less, sometimes it's high. Okay, it just keeps varying.
Ma'am, but if you
So
go to the depths of the ocean, ma'am, but then the water pressure will be the same, right? Meaning like it's okay if it's a little more, that means you go a little faster. But if it's less, that means you're still moving and you're covering ground.
still moving, yes, but sometimes still waters are also there in the ocean. Still waters.
Yeah, but ma'am, they still exert an amount of pressure, no, ma'am. Still water still exerts an amount of pressure because of
Yeah,
gravity.
yes, but a particular amount of pressure is needed to push it forward. Okay,
Ma'am,
you have to see.
I'm saying that this like you have this, and then you have the slope over here, and then you have a couple of wheels, okay? And what you basically want is like the pressure comes, and then it pushes you ahead, pushes the object ahead, like a
It is
rotor.
possible. Mm-hmm. It is possible. Yes, if under the right circumstances, the right pressure, it is possible.
Then that will let like explore not explore but like robots explore marine life for more longer because they don't need to, they just need a way to direct themselves, that's all.
We just need a way to direct them. Yes, yes, but like technology is needed still.
Yes,
Okay,
still.
along with science,
But man, you got
technology,
one of your major hurdles off. It will take less battery.
it will take battery,
Less battery.
less battery. Mm-hmm. Okay, yeah, all right. So, okay, let's like move forward. Okay, it's a good idea, and the science behind it is right. Okay, agree with it. Just that the resources is needed, technology is needed to like turn this into a plan. Okay.
Yeah, man, because the hull will also need to like be able to take immense amount of pressure.
Yes.
It
Yes.
cannot
It
fly
will.
instead.
Mm-hmm. Yeah. Okay. Now we were talking about how the body of fish is streamlined. They are pointed in anterior and posterior side. Okay, means the front and the back, they are like pointed. Okay, they are pointed from the front, then from the back, and the center is a bit wide. Okay, so it gives power to them to move in water easily. Simultaneously, the body is covered with scales, which also help in swimming. Okay, which also help the fish in swimming. Besides this, some marine animals live in greater depths or bottom line, like octopus, squid, starfish, etc. Their body is not streamlined, but they have many arms with which they catch their prey. When they swim, they can make their body streamlined. Most of the marine animals respire through gills, but some marine animals like whale, dolphin, etc., they do not have gills. Yes, Abraham.
Mom, is the fish is oval in shape, right? Kind of.
Oval shape, it's like a very flattened oval.
And then like with a square at the end. There's no at
Also,
the end.
also pointed. Like oval is not really pointed, but fishes are like pointed at the front and the back. Okay. So and oval is kind of like this. So it's like pointed also.
I'm squished oval.
Sorry, squished oval. Yes, squished oval. Maybe we can say that squished oval. Now, talking about some animals which live at the bottom of the sea. Okay, like this is the water, and they will live right at its bottom, like a starfish. Okay, it lives at the surface of the sea. Okay, octopus, squid, all of them. Now, they usually have legs, okay, to catch the prey. And if they want to swim, then they can make their body streamlined. Now, talking about octopus, okay, usually it is like this, okay. If it swims, when it swims, okay, when it swims, it makes its body like this, okay, and then like closes, opens, and then closes and opens. So that way he makes his body streamlined, okay. He makes his body, if you can see, like this, streamlined to swim in water. Okay. Yes, you have another question? Abraham?
Yes, ma'am. Ma'am. This is the reason like why they're able to get away from predators easily. They score
Yeah.
hits, yeah, extremely fast and they leave.
Yes, they swim very fast. Okay. Also, they leave this like substance. They release this substance when they feel threatened. Okay, when someone attacks them, they release a substance from their mouth, like it's an ink type of thing, black or maybe blue, that like blinds the opponent for some time, and in that time they can just run away, swim away. Okay.
Okay, ma'am.
Yes. Now, some marine animals like whale and dolphin, they do not have gills. So how do they respire? They respire through nostrils present in their head. Okay, now they can stay in water without respiration for longer durations. Periodically, they come on the surface of the water, expire carbon dioxide and take in fresh air through nostrils and then go in again. Okay, they have to come out on the surface like whales and dolphins. They breathe through nostrils and they like periodically after a period of time they come out to the surface and take in oxygen, release CO2 and then go back in. Okay. Water of ponds, rivers, lakes is sweet and they have variety of organisms and plants. Fish, crocodile, and tortoise are some examples. Now, lake water lake water animal examples are fish, crocodile, and tortoise. Okay, they live in lakes. This is an octopus, and that is a whale. Now, reefs are plants
I have a
similar.
question.
Yes.
And so whales and dolphins, like if they get stuck somewhere, like their fin hits something and then they're stuck, they will die in another hour or another few minutes.
They will die in another few hours, in a few minutes. Look it up, Abraham. Okay, that how long if they're stuck, so how long can they last? Or if they can last on the molecules of oxygen that's dissolved in water. Okay, for some time when they are not getting the outside oxygen, can they live on the oxygen that is dissolved in water? Okay, and how long can they go without it? All right. Now, reefs.
Uh,
Yes.
then why is there no device that splits carbon dioxide to form oxygen?
Why is it?
Why is there no device that will split carbon dioxide to give oxygen?
Why is there no device to split carbon dioxide to give oxygen?
Yes, ma'am.
Um, how can carbon dioxide be split to give oxygen?
Is because carbon dioxide has two carbon atoms, one oxygen atom. So if you take two particles of carbon dioxide, you'll be able to make one particle of oxygen. Two is to one. Because oxygen is two particles.
Okay. All right. That too, you can look it up. Okay, if there is such a device that splits carbon dioxide to give oxygen. Okay. Now, now we have some plants that are living in water. Okay. Besides animals, besides fish, we also have plants that live submerged in water. Okay. Reefs are plants that are similar to algae. They either float on the surface of the ocean like planktons or hold rocks on the side so they do not move away with sea tides like kelps. Stem of plants living in water is hollow, which facilitates them in swimming. Stems of some plants are below water, and the leaves and flowers are floating above on the surface like lotus. Okay? Some other plants have leaves inside the water, or they are thin and flat like ribbon, so they do not break in waves of water like Vallisneria. Okay, you can see this one.
Question.
Yes.
When do plants have to swim?
When do plants have to swim?
This one.
Okay. So basically, they do not travel all around the water. Okay, no. But plants sometimes it might be there that it's like a tide something. Okay, and the pressure may be high. Okay, so water is rushing. So that time the plants, if they are flexible, okay, they are very flexible. So they'll just like bend this way or this way, but they will not break. Okay. Usually, what happens to our plants on land is when water is coming, rushing, the plants seriously they just break. Okay. But water plants are like thin and their stem is very flexible. It's not rigid. Okay, it's very flexible. So water is coming this side, they'll just bend this side. When the pressure is gone down, they'll just stand back again like this. Okay.
So basically, they're not swimming, they're swaying like trees.
Yes, they are not swimming, they are swinging. Okay, and the lotus, some are floating also, okay, like the lotus flower.
Our plants do the same thing, but for the wind.
Our plants, yes, our plants do the same thing, but for wind, water pressure, they cannot stand. Okay, okay. Now, some of the animals live on the shores of the water, like frog. They can live inside or on the side of water. Okay, some animals are there which can either live on the side of water, okay, means on land also, and in water, inside the water also. So they have larger rear legs and their fingers have network which help them in jumping for catching prey and swimming. Okay, webbed feet is there. Yes, Anju. Manisneria is submerged underwater, wholly submerged underwater, and it's also very flexible. Okay? Yes, Abraham.
What does it mean that their fingers have network? Does it have internet?
No, not internet, but their fingers are like connected together through a like network of veins, okay, and some flesh also. They are like connected together, okay. So that helps them in jumping for catching prey and swimming. Like if it is like this frog's finger, then they'll keep like this. Okay, the network keeps them connected, so they can easily like jump and catch the prey. Okay, and their legs are also the back legs are also long. Okay, so in this way, in nature, frogs are adapted to survive inside water and outside water as well. Yes.
Another question. How can things live inside plants? Like it says like they can live inside or on this like it says they live inside plants, right?
I didn't got the question. Say again.
Okay, ma'am, no. My question, ma'am, I got the answer.
Got the answer. Okay. Now comes adaptation. With all examples given above, we can understand that organism lives and stays at a place. Okay, their body structure and food are adapted accordingly, according to the place that they are living in. According to that only, their body is adapted. Okay, their food is also adapted. Different shapes and habits of organisms, which help them in survival in their surroundings, is called adaptation. Now, this is the adaptation definition. If you want, you can write this down. Different shapes and habits of organisms, which help them in survival in their surroundings, are called adaptation. Okay. In this chapter, we are able to express about only a few organisms and plants. Living organisms are present everywhere, on land, water, air. Now, some very small microorganisms like bacteria are found in snow covered Antarctica, as well as boiling hot sulfur springs, living successfully. Their cellular organization helps their survival in such extreme conditions. Okay, microorganisms exist in extreme conditions. Okay, yes, Abraham.
Yeah, ma'am, my hand was raised mistakenly.
Okay. So a while back, one news came that a virus had been found at, I don't know, it was Antarctica or someplace, frozen. Okay, it was found like frozen. Okay, and it ranged back to hundreds of years old. Okay, and it was named zombie virus. Okay, so when I read the headline for the first time, zombie virus discovered. Okay, so I was like, oh my god, zombie virus, really? Okay, zombie virus, literally zombie virus is discovered. Okay. So what will happen now? I was like very curious and like because the name was zombie virus. Then later, when I read about it more, I got to know why they named it zombie virus is because it was like living and dead at the same time. Okay, dead how? Because it had been buried, frozen for like hundreds of years, but still alive. Okay, that is why it was known as zombie virus. Okay, so see, this is how like microorganisms are there who survive, which can survive in extreme heat, extreme cold for years and years. Okay, so that is their adaptation. Like they are adapted to survive like that. Okay, even the microorganisms, their cells, their structure is like designed to survive like that. Understood? Adaptation.
Yes, ma'am.
Okay. Mind map on one animal and its adaptations. Okay. Tell me, how do you plan to do it?
Ma'am, we draw a circle, we write the name of the animal, and then we draw a few different lines explaining like what it's like, saying its adaptations.
Okay. Okay, yes, we can try this out. Um, so in the next class, we will do this activity. Okay, it's a good activity. A mind map on one animal and its adaptation. So you all can think of your animal, okay, until now, until tomorrow. And tomorrow we can make a mind map of an animal and its adaptation. Okay. Okay. So with this, we have finished with this chapter. Okay. With this, we have finished with the second chapter. What I want you all to do now is try out the back questions. Okay. Try out 2.3. Okay. And end of chapter questions. Take 3 days. Okay. Take 2 to 3 days and figure all the questions out. Okay. Soon we'll be having the test for this chapter. So y'all first like do the answers, go through the question and answers, okay? And let me know if there is any doubt in any of the question. All right, we'll be starting a new chapter in the next class. Any doubt, Anna? Hope everything is clear.
No, ma'am.
Okay. Abraham?
Ma'am, just one question. What if I've already done most of the exercises?
If you've already done, you can just go through them as revision, okay?
Okay, ma'am.
Okay, so 5 minutes break is there right now, and then we'll start with the math class. Okay, let's begin. Hello, Nathaniel. And can I have your videos on, please? All of you. Abraham and Anna. Hope you all are there too. Okay. So in the last class, we finished with the properties of whole numbers and natural numbers. Okay, we saw the properties of zero. Okay, how it works. And what are all the properties that are used in zero. Okay, that we saw. And today we are going to start with factors and multiples. Okay, factors and multiples. Okay, now first we will see that what is a factor. Okay, let's take any number. For example, 6. Okay, so a factor is basically those numbers that when divided by any number, then the remainder will always be 0. Okay, means that those numbers in whose table 6 is coming. Okay, or those numbers which are dividing 6 completely, that what answer we will get is 0. So 1 is the factor of every number. Okay, 1 is the factor of every number. Then we have 2. Okay, 2 threes are 6. Then we have 3. Okay, 3 twos are 6. And then that number itself is also a factor 6 by 6 ones are 6. Okay, understood what is a factor? Like in the table of 1, 6 is coming. Okay, 1 into 6 is 6. In the table of 2, again 6 is coming. 2 into 3 is 6. In the table of 3, 3 into 2 is 6. And in the table of 6, 6 into 1 is 6. Okay, so that means 1, 2, 3, and 6, all of them are factors of 6. Okay, this is the meaning of factors. Okay, so you can write a number, you can write the definition. A factor of a natural number is the number which may divide it exactly. Okay, so 2, when I'll divide 6 by 2, I will get 3. Okay, I will not have any remainder left, okay, but it will be a complete division. All right, so that is what a factor is. Okay, like in simple terms, those numbers in which will exactly divide our main number. So those numbers will said to be the factor of that number. Hello, Shriyan. Good morning.
Good morning, ma'am.
Can I have your video on, please?
Okay, 5 minutes later, can I on teacher, please?
Okay, sure. Okay, so this is a factor. Okay, understood factor. Any doubt in factor?
No, ma'am. Ma'am, can you give us a question to solve?
A question to solve. Okay, I'll be giving you all a question to solve. Like I'll be teaching you all how to find factor of larger numbers. Okay, but you can just find out for 18 right now. Okay, all the factors of 18. Okay, and do this, and then because this can be done verbally also. Okay, you all know the tables, so this will be done easily. Okay, but there is a method called HCF to calculate the factors of bigger numbers. That I will teach you in the upcoming lessons.
None of the factors 1, 9, 2, 6, 3.
Okay. Yes, Abraham, it is correct. Okay. And the number itself will also be a factor. Okay. The number itself will also be a factor. So the factors of 18 will be 1. 1 into 18 is 18.
1, 2.
2,
Teacher, for 18, the factor is 3, 1, and 6, teacher.
3, 6, 9 is also there,
9, 2, yeah.
and 18. Okay.
Yes, ma'am.
Yes, yes, Anna. I mean HCF and LCM. Okay. I'll be teaching you all HCF and LCM for bigger numbers. Small numbers, we can just calculate the factors verbally. But for bigger numbers, we need a method. Okay. Methods are known as HCF and LCM. But that we will do later. First, I'll teach you what is a multiple. Okay. Right now we saw what is a factor. Okay. Now we'll take a look at what is a multiple. Okay. Anybody wants to tell what is a multiple? Any idea?
Yeah, my idea is that it will be a multiplication, teacher.
It will be a multiplication. Yes, we can say that.
Yes, ma'am. It can be like if I want 20, 10 twos are 2, like the 2, 10.
Okay. See,
Ma'am?
multiple.
Yes.
Yes.
Ma'am, a
Yes.
multiple is like the amount, like a multiple is the product of when you multiply two numbers, like how many times you add it. Like a multiple is like you add a certain number an amount of times, the answer you get is called a multiple.
Okay. Okay. Yes, Abraham, that is right. Okay. That is right. Now, we will take an example. Okay. Suppose I have 2. Okay. So, all the numbers coming in the table of 2 will be its multiple. 2, 4, 6, 8, 10, 12, and so on are its multiples. Okay. Then if I take a number 3, then when I go on in the table of 3, it will be its multiples. Okay. It will be the multiples of 3 and so on. Okay. So These are the multiples of 3 and 2. Similarly, these are all the numbers of multiples of the numbers. You can write the definition of multiples. A natural number is called the multiple of each of its factors. Each of its factors.
Hello, ma'am.
Yes, Shriyan.
I can understand. I understand. Like, what help us, please? Okay. Thank you, ma'am. One more doubt I have. Can I ask you?
Yes, you can ask.
If it is like 100 of multiples means factors means what will be the 100 of factor for hundreds?
Factors for 100.
Yes, ma'am.
Okay.
Ma'am, can I say, ma'am, please?
Yes, Abraham. Say.
100, 2, 50, 4, 25, 5, 20. That's all.
And one
Very
more
good.
number is there, teacher. Can I tell that number?
Yes.
10 also can be factor of
I
100.
see, ma'am. 10, 10.
10 is there. Yes, 10 is there. Good, Abraham and Shriyan. Good. We have all these numbers. Okay. That is correct. Even 1 will be the factor. Okay. And 10 itself will also be the factor. Because 1 is the factor of every number. Why? Because in one's table, every number will come. Okay. And the number itself, that in the table of the number itself, that number is coming. Suppose 100 into 1 is 100. So 100 will also be a factor and 1 will also be a factor along with all the others like 5, 50, 10, 25, 20 along with all the others. 1 and 100 will also be a factor. Okay. Now what will be the multiples of 100? Anyone? Multiples of 100.
Ma'am, can I?
Yes.
Ma'am, 100, 200, 300, 400, 500, and so on.
So on. Very good.
And 900 also it can be, and 1000 also.
Yes. So on. 900,000. Okay. Then 1100, 1200, 1300, 1400. So on. Okay, all of those will be the multiples of.
Ma'am, the possibilities are infinite.
Yes, possibilities are infinite. Okay, now, see, we know what is an odd and even number, right? You know what is
Yes.
an odd and even number? Yes. So, odd numbers are those numbers ending with 1, 3, 5, 7, and 9. Okay, these are odd numbers. And even numbers are numbers ending with 2, 4, 6, 8, and 0. Okay. So example, if I take a number 377, it is ending with a 7. Okay. Means that it is an odd number. And if I take another example, okay, 304 ending with 4, and 4 is an even number, so this whole number will be even number. Okay, this is about odd and even number.
No, understood.
Okay, Ritu?
Yes, ma'am.
Okay. Now there are also two types of numbers. Okay. There are also another two types of numbers.
Ma'am,
Okay.
prime and composite numbers.
Yes, prime and composite numbers. Now, what are prime numbers? Anyone?
Ma'am, can I see?
Yes.
By 2, teacher?
Ma'am, numbers are
Sorry.
numbers that
It's
are,
a divisible by 2.
that are only multiple, see, only have the factors of 1 and they are self. Composite numbers are numbers that have other factors.
Yes, correct, Abraham. Okay, prime numbers are those numbers which has only two factors. Only two factors. One and the number itself. The number itself. Okay. For example, if I tell you to give me the factors of 7, okay, give me the factors of 7. Nathaniel, what will be the factors of 7? Yes, factors. Factors of 7. Seven is coming in the table of what numbers?
7 tables, then one teacher, 7, 1, 7, then other tables, no.
Yes, Shreya, that's right. Okay, so Nathaniel, see, 7 is coming in only the table of 1. 1 into 7 is 7, and 7 itself. Okay, so the factors of 7 are 1 and 7. Okay, so that therefore the 7 is a prime number. Okay, therefore 7 is
Like,
the
if it is divisible by itself and 1 is the prime number, teacher.
Yes. If
It's
it is
like 9 is not divisible in other tables.
Yes.
9,
Okay.
no. 1 minute, teacher. 9 is a prime factor.
9 is not a
And 9
prime
is
number.
composite is because
Got
it
it, got
is in
it.
3 times table.
9 is a composite number. Okay.
Yeah.
Okay.
So, ma'am,
Yes.
basically,
11 is a prime number, teacher. It's divisible by 1 and 11.
Yes. 11 is a prime number
Mm.
divisible by only 1 and 11.
ma'am, basically prime numbers are numbers which cannot be divided by any other number than 1 in itself.
1 in itself. Yes, Abraham, that's correct. Now comes composite numbers. Okay. They have more than two factors. Okay. Those numbers having more than two factors.
Yeah.
Okay. For example, 12 What are the factors of 12? Anna, what are the factors of 12?
Ma'am, she left the meeting.
I think she left accidentally. Okay, anyways, Nathaniel, what are the factors of 12? 12 is coming in the tables of what numbers?
Can I tell?
One
Yeah,
second, Shriyan. 1 second, Shriyan. One.
I know this answer, but I can't. Can I tell, please?
1 second, let Nathaniel tell.
Nathaniel, okay.
One is there, then two, then
Uma,
three, four, six, very good, and 12 itself. Very good, Nathaniel, very good. We have the factors of 12, 1, 2, 3, 4, 6, and 12. Okay, those are all the factors of 12 that we have. So now look at the factors. There are more than two. Like beside 1 and 12 itself, there are many numbers in between which are dividing 12. So that means 12 is a composite number.
yes, teacher, correct.
12 is a composite number. Now,
Yes,
can you give me some of the composite numbers, other composite numbers? One, all of you can give me, okay?
Yes, ma'am.
We will start with Abraham. Give me one composite number.
Composite number on this.
Ma'am, a composite number could be...
Ma'am, 13?
No, 13 is not a composite number.
13 is
Ma'am,
divisible.
a composite number could be 22 because it's divisible.
22.
Mm,
20. Good.
22.
Okay. It's okay, Anna. You can just answer in the chat box. Okay?
It's a prime number, teacher. But how can it be divisible, teacher? 22.
22 is divisible with 2.
Can I explain, ma'am? Can I explain?
2
Yes,
and
Abraham.
Ma'am,
11.
yeah,
yeah,
11
11.
is because that
2, 11 and 22 itself.
Shriyan, a
One
trick
more.
uses that no even number except for 2 can be a prime number is because all of them will come into multiples of 2. Is because 2 takes away all even numbers.
Oh, okay, got it.
That's Abraham. That is perfect. Okay. Good cause. See, all the in the table of 2, okay, all the this even numbers will come. Okay, 2, 4, 6, 8, 10, then 12, 14, 16, 18, 20. All the even numbers will come in the table of 2. So when they're coming in the table of 2, then all the even numbers except 2 will be composite. Okay, not prime.
Okay.
So this was a good cause. Now Shriyan, give me one composite number quickly.
If it is like composite means 24, teacher, it can be
24. Yes, it can be 24. Nathaniel, give me one composite number. Didn't understand. Wasn't able to hear.
the number 12.
12. 12 is written already. Give me something else. 32. Okay. Yes. 32.
How is the this number is 32? It can be hidden under.
How can it be 32?
Shriyan, use the rule. Every even number except for 2 is a composite number.
Composite number. Yes, is a
Oh,
composite
like
number.
God.
Okay.
Okay.
Anna, give me a composite number.
52 and then 42 and 42. Yes, it's 6.
Are you able to hear me, Anna? 16. Yes, 16 is a composite number. Okay, definitely 16 is a composite number. So understood now what are prime numbers and what are composite numbers? All of
Yes,
you all?
teacher.
Okay,
Mm.
all right.
Oh,
Okay,
it's composite number, sure.
Mom,
Ritin,
will we do
Ritin,
twin primes today or will it be done tomorrow?
twin primes, we can do it today, Abraham. Okay, we can do twin primes today. Okay, have you all written what's on the screen? Prime number and composite number, definition and examples.
Ma'am, if we go to a book, ma'am, we can see a chart on prime and composite numbers.
Yes, we can see a chart on prime numbers. Let me
Yeah. Ma'am,
check
I
if I
have
can.
a doubt. Sorry for disturbing yesterday's math class. What should I do, teacher?
Yesterday's
Math class.
maths class. Okay, so Shriyan, math class, I have updated the link on the group. Okay,
Uh,
I have updated the link on the group, so you can go through it. You can open the link, so the recorded class is there. Okay, the recorded class is there, so you can listen to it. Okay, and ask your doubts tomorrow.
yes.
All right. Okay. So now in front of you is a chart of prime numbers, okay? 2, 3, 5, 7, 11, 13, 17, 19, 23, then 29, 31, 37, and all of them are the prime numbers.
53,
Okay?
59,
Ma'am,
61,
ma'am,
67,
Yes,
71, 73, 79,
yes, Abraham.
97, 97. Okay.
ma'am, the prime number and a composite number, meaning like they aren't equal. There are no the same amount of prime numbers for the same amount of composite numbers, right, ma'am? And the
They are not
higher
equal.
numbers you choose, the less
Ma?
higher you go, the less there is a less chance
Ma?
for a prime number.
Yes, we can say that. Okay, prime numbers are lesser, but composite numbers are more. Okay, now what we will see next is twin primes. Okay, what is a twin prime? What is a twin prime number? Okay, so twin prime numbers are those prime numbers which have a difference of 2. Okay, which have a difference of 2. For example, take a look at 3 and 5. Okay, 3 and 5. They are at a distance of 2. So if I do 5 minus 3, I will get 2. So 3 and 5 is a pair of twin prime. Okay, it's a pair of twin prime. Okay, similarly, take a look at 5 and 7. 7 minus 5 is 2. So this is again a twin prime. Okay, then look at 11 and 13. 11 and 13. 13 minus 11 is 2. Again a twin prime. 17 and 19 here. Okay. Twin prime. Yes, difference is 2. Okay. They are just 2 time apart. 2 number apart. Okay. And 41 and 43. Okay. Another twin prime. All right. Then we have 71 and
71 and
73.
73.
Yes, 71 and 73. Another twin prime. Okay. So all these sets of twin primes we have in up to 100, we have 1, 2, 3, 4, 5, 6 sets of twin prime numbers. Okay, twin primes. Understood what is a twin prime? Twin prime. Okay, these are known as twin prime numbers. Means that they have a difference of 2.
Ma'am, in the book it says 2931.
29, yes. 29 and 31 is there. 29 and 31 is there. It was because it was up and down, I was unable to locate it. Okay, but 29 and 31 is also another pair of twin prime. Okay, understood all of you? Okay. You can write down the definition of twin primes.
Ma'am, a twin prime are prime numbers which the difference is 2.
Yes, yes, Abraham. Written till here? Okay, so let's quickly see one more part. Okay, one more part. Now, another term is co-prime numbers. Co-prime numbers. Okay, two natural numbers are called co-prime numbers if they do not have any common factor other than 1. Okay, now common factor. Now try to understand this very carefully. Okay, let's take 3 and 4. Okay, what are the common factors between 3 and 4? 3 and 4 comes in the table of 1. Okay, both come in the table of 1. Okay, oh, sorry, let's write the factors of 3. 3 factors of 3 is 1 and 3 itself. Factors of 4 is 1, 2, and 4 itself.
I have a question.
Yes. Yes, Abraham.
About co-prime. What's the point of co-prime?
What's
Every
the
co-prime number will be different, right, ma'am?
every co-prime number will be different. See, co-prime numbers are in pairs. Okay, they are in pairs. Okay, and yes, they will be different. Okay, but what is the main thing is that now I have listed the factors of 3. Okay, and I have listed the factors of 4. So, what is the common factor? Only one is the common factor. Okay, only one is the common factor. If I take 4, suppose take another example. Let's take two other numbers. For example, 4 and 6. Write the factors of 4, 1, table of 2 and table of 4. Write the factors of 6, 1, table of 2, table of 3, table of 6 itself. Okay. Now, what are the common factors in 4 and 6? 1, then 2 also is there. Okay. So, common factors here are 1 and 2. Two numbers are common factors.
Okay,
Okay, two numbers. So, this is not a co-prime. This is not a co-prime. Okay, why? Because it has two common factors. Okay, co-prime will only have one as the common factor. Co-prime pair, this is the co-prime pair, which has only one as the common factor.
Okay, ma'am. Ma'am, so that means that there cannot be like even. There has to be odd or even odd, right, ma'am? There'll never be
Odd or even odd, that depends, Abraham. Again, I don't know if there's really a pattern here, but the only main thing is that only one should be the common factor.
no, but there is a pattern, no, ma'am. It's because like if it's both an even, you'll have two as the common factor.
Yes, even it cannot be.
Odd, you can. It is possible, like 3, 5.
3, 5, yes. 3, 5 only has one as a common factor.
And an odd even is also possible, like 3, 8.
Odd and even, yes. Okay, yes, it is possible, Abraham. Okay, it is possible. Now you all can write the definition of co-prime numbers. Those numbers, write that down. Two natural numbers are called co-prime numbers if they do not have any common factor other than 1. You can write some examples. 2 and 5. Then we have 3 and 4. 3 and 7. 2 and 7. Okay, these are some examples of co-prime numbers. Hope it's clear to you. Okay, so we will stop here for today. Okay, homework is exercise 1.6. Okay, 1.5 and 1.6. You all can try out. 1.5 is very easy. Just 5 fill in the blanks you have. Okay. And 1.6 is there. So please try out exercise 1.5 and 1.6. Okay. Okay. Okay, then we'll meet today now. We'll meet tomorrow.